So the good thing about complex numbers questions is that there's nearly always free marks going, really, okay? And a well-prepared student this year, as soon as they saw this, their eyes would have lit up, right? Because this is a very straightforward de Moivre's theorem question. Okay, so you have your, and like, you know your steps inside out at this point. So you get your modulus, plot your point on the Argand diagram. The modulus is that distance, don't forget that always, that's the distance from the complex number to the origin. Formula is very straightforward, so the modulus in this case is 2. And the argument then is the angle that it makes with the positive x-axis. So it's this angle here. Now, some people do different methods to find the argument. What I do is I find this angle first and then subtract it from 180 in this case. And again, I use radians. Okay, now you can use degrees as well. Obviously, that would be 30 degrees, that angle in there. So this angle must be 150 degrees, or pi minus pi over 6, which is 5 pi over 6. That goes into your formula for polar form. And we want z to the power of 4, so we use de Moivre's theorem. So that's 2 to the power of 4, and you're multiplying your angle by 4 then as well. Okay, and once you have that done, type it into your calculator, and there you have your answer. So like imagine that was 15 marks this year for a very, very straightforward de Moivre's theorem question. Now, the problem with that is usually when that happens, it means there's something bad happening in part B, right? Because they wouldn't be giving 15 marks for something that easily if that was the case. Now, before you start part B, there's a rule in complex numbers. Now, unfortunately, this rule is not in your log tables. Okay, it's just something that you would have to remember. It's in your course, it's on your book, but it's this rule here. Okay, that don't be turned off by all the terminology here. It just means that if you have two complex numbers that are both in polar form, and if you want to multiply these two complex numbers, then all you have to do is multiply the modulus, the two modulus or moduli, and you add the angles. Okay, now if it's dividing, you do the same except you subtract the angles. Okay, but it's this rule that's going to apply now in the next question. Okay, just keep that in mind there for the next question. Now, let's have a look at this question. Now, at first glance, it's very difficult to see what's happening here. A lot of students would have been completely turned off by this. But any keen problem solvers would have said, right, what'll I do here? Well, let's draw a diagram. Okay, now it doesn't tell us anything about the complex number here, but it says it makes a 30-degree angle with the positive sense of the real axis. And what does this mean? Well, that's the symbol for modulus. So the modulus of it is 3. So if we draw a diagram of it, right, even with this little bit of information, we know it makes that angle there is 30 degrees, and that is 3. Now, that is the modulus of the complex number. This is the argument. Okay, so if you know your de Moivre's theorem or your polar form inside out, you will know that we now have enough to put this into polar form. Okay, so we have this complex number now in polar form. So we have W now in polar form, and we can write it in standard form as well if we want. Now we also have Z from the previous question in polar form. Okay, now what we could do here is just simply use that rule that I alluded to earlier, that if I'm multiplying two complex numbers, I simply multiply the modulus and I add the two angles, and that gives me my two answers. And when I convert that into standard form, then it comes out as -6. Now that was worth your remaining 10 points in this, and if you look at it, if you make any effort to put it into polar form, that's low partial. If you get to this line and stop, right, that would be 7 marks, 7 out of 10, which isn't too bad. And if you make any effort at this, I suppose you end up, or if you get down as far as here, you end up with 8 marks out of 10. Okay, so if you had that little trick up your sleeve, you were getting full marks here fairly easily. Now, a longer method to do this would have been, now sometimes if you don't know what W is, you just write it as A plus BI. Okay, now we know that the modulus is 3, right? So what you could do is you could draw out the diagram, and that's A and that's B, and you could express the modulus in terms of A and B. Okay, so like this, and so we know it's equal to 3, and if we get rid of that square root there, we get an equation with A and B. Now, this is where it gets a bit complicated. So we also can express the argument in terms of A and B. Okay, now we know that the argument is 30, so we can say that tan of 30 is opposite over adjacent, so that gives us this equation. tan of 30 is 1 over root 3. So we can rearrange this and get a value for b and do a kind of a simultaneous equations job here and substitute that value for b in here. Okay, so that gives us this. Now it's just algebra then after that. Now it's kind of complicated, so it's not a very appealing approach to taking this. So square out your brackets, multiply across by 3. We get a kind of a quadratic, a simple enough quadratic here to solve. A comes out as 3 root 3 over 2. And we don't have to worry about the negative version of it. I know it should be minus root 3 root 3 over 2 as well, but we know it's in the positive sense, so we don't need to worry about the negatives here. We then take this equation, sub it back into our original equation, and b comes out as 3 over 2. So now, unfortunately, we still have a small bit to go because we're not looking for w, we're looking for t. Okay, so if we go on and continue, so we now know what w is, we know what z is from the previous question, and now we need to multiply them out to get what t is. Multiply them out. Small bit complicated there now because we have all these fractions and all that kind of stuff. Split and repeat here. Don't forget about the I squared. But eventually, and you have to kind of trust me in this, when you simplify all that down, it also comes out as minus 6. Okay, so definitely a longer method there. You still only get 10 marks for doing it the very long method, but this would have been a very, very troublesome question this year. And the interesting thing is the vast majority of students would have got the part A right, whereas this part B was one of the worst answered questions this year as well.